Panditare, sir. Shall we start, sir? Sir, please unmute your mic, sir.
Good morning, all.
Good morning, sir.
Good morning, everyone. I would like to thank everyone and the Sri Ranganatha Institute of Technology, the principal, the staff members, and all the dignitaries for this wonderful opportunity. So today we are going to discuss on the topic of sustainability and energy efficiency through renewable energy sources. Let me share the screen with you.
Sir, is there any problem, sir?
Yeah, the sharing presentation is not opening. Let me check. I'm
Okay, sir.
logging in another system.
Yes, sir. Thank you, sir.
Please allow me in. I'm trying to open from another system. Ma'am. Hello.
హలో
Sir, screen is visible now, sir.
Okay, ma'am.
Okay, sir.
Am I audible to everyone?
Yes, sir. Participants, please respond. Anybody?
Yes, sir.
సార్ ఇట్ ఇస్ ఆడిబుల్ సార్.
Yes, sir. Thank you, sir.
So, good morning, everyone. My name is Pandit Rayalavel, and I am happy to present on a topic critical to our future: energy efficiency and sustainability. As the founder of Reason Energy, I have spent over a decade of experience in renewable sector, particularly solar. So, solar energy to promote sustainable solutions. Today, we will explore how these concepts align with civil engineering and how solar power, in particular, plays a transformative role. So, introduction to energy efficiency and sustainability. Let's start with some basics. Energy efficiency is about doing more with less energy, optimizing resource use while minimizing waste. So sustainability, on the other hand, ensure we meet our needs without compromising the ability of future generations to meet theirs. Together, these principles create a framework for reducing environmental impacts, improving building performance, and aligning with the green certifications like LEED and IGBC. So the current state of energy use in civil infrastructure. So in global energy consumption, these are the figures. Like buildings are responsible for nearly 40% of global energy consumption. And construction activities contribute to 38% of global CO2 emissions. These numbers highlight the urgent need for change. Civil engineers are in a unique position to address these challenges by incorporating energy efficient designs and renewable energy solutions. So, when it comes to principles of energy efficient design, uh, it begins with thoughtful planning. Proper site orientation can maximize natural light and ventilation, reducing reducing reliance on artificial lighting and HVAC systems like heat, ventilation, and air conditioning systems. Choosing low carbon materials. So material selection itself plays a vital role in this. So choosing low carbon materials like recycled steel or fly ash lowers the embodied energy of construction. Additionally, high quality insulation and sealing prevent energy loss, significantly improve building performance. So when it comes to sustainable building practices, sustainability in construction involves integrating renewable energy like solar, wind, or geothermal systems, water conservative through rainwater harvesting, and grey water recycling is equally vital. Green roofs not only improve insulation but also add biodiversity and aesthetic value to urban areas. So the best practices start with uh, these key points of adapting to renewable energy, water management, and green roofs. So energy efficiency in civil engineering systems. HVAC optimization, lighting efficiency, and smart technologies. Civil engineering systems like HVAC and lighting are major energy consumers. Optimizing these systems with energy efficiency, such as LED lighting and smart building management systems, can drastically reduce energy use. Incorporating IoT enabled real time monitoring and automation ensures resources are used efficiently. So, the role of civil engineers in promoting sustainability, there is policy advocacy, education, innovation, and a long term vision. Civil engineers are the key to advancing sustainability by advocating for green building codes, educating stakeholders, and adopting innovative technologies. Engineers can design solutions that reduce waste, maximize resources, and align with the principles of a circular economy. So, when it comes to future trends in sustainable constructions, there are net zero buildings that are designed to generate as much energy as they consume, reducing their carbon footprint. Advanced materials utilizing self-healing concrete and carbon sequestering materials to enhance sustainability. And then there is the AI and big data and the smart city projects. So the future of construction is shaped by innovation. Net zero buildings generate as much energy as they consume. Advanced materials and then AI, they play a vital role in this one. From this, I'm going to present a small intro about harnessing solar power for energy efficiency and sustainability. This presentation highlights the importance of solar power in energy efficiency and sustainability within civil engineering. So, solar power, the future of energy. It's clean energy. Usually, we are going with conventional energy sources, which is called non-renewable energy sources, like fossil fuels, like petrol, the coal. They are using in thermal power plants, hydroelectric power plants. Hydro itself is renewable, and conventional like non-renewable sources like fossil fuels are depleting. So clean and green energy is solar, wind, and this hydro plants. Those are all clean energy and green energy because they are renewable, and there is no any carbon emissions. uh, it it contribute to the environment, and you can generate more energy when compared to conventional energy sources. And cost effective solution is going with the solar power, like long term savings means when you are investing on solar, you get return on investment within 3 to 4 years, which is about 25%, 20 to 25 percentage of
Sir, sorry to interrupt, sir.
yeah.
Slides are not moving, sir.
1 second.
Okay, sir.
Is it? I'm still on the same slide, ma'am.
Yes, sir. Okay, sir.
Okay.
Thank you, sir.
So, you're not getting slideshow? Okay,
No, sir.
1 second. And then I was talking about return on investment, right? So return on investment is 3 to 4 years, which is very good investment, very good energy investment. When you go for any kind of investment, the returns will take more than 10 years also. But here you are getting the investment within 3 to 4 years, means it's a very good energy investment, and you get to start generating your own electricity for the rest of system life, which is around 30 years. There is warranty, so which means 25 plus years you generate your own energy for free of cost. The initial investment you can recover within 3 to 4 years, and it's very much reliable source. And the energy challenge in civil engineering. Civil engineering accounts for a significant share of global energy consumption. Buildings alone use nearly 40% of energy, with a sustainable portion wasted due to inefficiencies in design and construction. So, the urbanization accelerates the demand for energy efficient infrastructure becomes more critical. By integrating renewable solutions like solar power, we can address these challenges and create sustainable cities. So, solar power, a game changer in energy efficiency. Traditional grids lose significant energy during transmission losses because you generate energy somewhere and transmit through transformers and transmission lines. There might be plenty of loss during energy transmission. Solar power eliminates this issue by generating energy directly at the site, and you generate, you consume, and you export the whatever the excess, you can export it to the grid with zero fuel cost and minimal energy loss. Solar power is not only efficient but also highly adaptable for various scales of implementation. So there are two technologies. You can generate light to electricity, you can generate your own energy, and there is thermal system which converts light energy into heat energy, which you can see in residential or commercial buildings. You can find solar water heaters. It works on solar thermal and solar power plants, which in turn generates uh, electricity for your consumption, and you can export it to the grid. So solar power and sustainability. When we think about energy generation, we should think about carbon credits, like how much carbon dioxide, like carbon CO2 savings happening by going with these kind of new technologies. For example, a 10 kilowatt solar system can save up to 15 ton of CO2 emissions annually. So solar power promotes environmental sustainability by reducing carbon emissions and fostering resource conservation. By harnessing the sun's energy, we contribute to a greener future, promoting energy independence and economic growth. So solar power aligns perfectly with the sustainable goals. It drastically reduces carbon emissions and promotes resource conservation. So types of solar applications in civil engineering, we can go with the rooftop solar system. Rooftop is nothing but you can install solar within the premises. We can develop a system which generates your own energy, and you generate, consume, and you can export the excess energy, which will be credited into your account. By the end of month, it will be adjusted, it will be adjusted to your electricity bill. For example, in household systems, there is a PM Surya Ghar scheme. Government is giving so many subsidy programs and funding programs for going solar. So if you are installing in your residential rooftops, like if you are consuming around 1,500 or 2,000, you can invest 1. 9 lakh. 78,000 subsidies there. Balance amount you can get even through less percentage of interest. Loan schemes are available through all the nationalized banks. So whatever you invest, you will get returns within 3 to 4 years, and the rest of system life you are paying nothing to the electricity board, which means literally zero electricity bill. This is also very much helpful in commercial and industrial sectors, where the daytime consumption is huge. They can start generating their own electricity by installing on their industrial rooftop or commercial rooftop, and cut down the electricity cost in daytime. So, which can reduce energy consumption from 60 to 80% in the daytime. And the solar street lights, which you may have seen in highways and campus of industrial or academic campuses. So it contains battery and it's a basic operation. It has a dusk to dawn operation. Basically, it works from dusk to dawn without any manual operation. And energy efficiency in solar powered infrastructure, as we discussed already, net zero buildings and the smart grids, integration with IoT, these are all going to reduce the dependability on conventional sources, and we can efficiently use solar power and reduce peak energy demand. Like in the peak hours, in the morning and the evening hours, there will be very big peak demand. So you can generate, even store. There are energy storage systems recently coming up. So Ieesms, we call it as, you can generate and store it in the on the lithium batteries, and in the peak demand it can be used to cut down the peak hour charges of industries. And also integration of IoT and smart remote monitoring systems helps to analyze the real-time data, and it gives exact prediction of energy generation in the upcoming days and months. So smart cities, as you may know, there are different options for smart cities development: street lighting, traffic signals, electric vehicle charging, data collection centers, and real-time monitoring. So the future trends in solar and civil engineering. It starts with BIPV, building integrated photovoltaic systems. So which are very much efficient when compared to rooftop systems. You can integrate into your building. There are latest technologies and advancements happening in this field. So it gives a seamless energy generation with the aesthetic look. And floating solar farms, those are all happening in Gujarat, and even Kerala recently done on a solar farm on the pond or lake. And solar desalination plants and next generation panels. There are a lot of efficiency improvements. When the efficiency improves, the space occupancy on the rooftop or on the ground, it decreases. So let's work together to build a more sustainable future, fostering innovation, collaboration, and a shared commitment to environmental responsibility. Thank you. And if you have any questions, we can discuss on it.
Sir, sorry to interrupt, sir. Sir, actually, the slides are not never. The first slide is all on all the time, sir.
But you don't told. Oh
Sir,
my God.
already. Yes, sir.
It was moving, right?
No, sir.
One,
No, sir.
1 second. Let me
Okay,
check.
sir.
Is it clear, ma'am?
So slide is clear, sir, but not never moved, sir. Yes, sir. Just now it's moving, sir.
You could have told at the starting slide itself, no?
Sir,
It's
yes, sir.
almost done.
Yes, sir, but I tried, sir. But you just told that I'm explaining in the first slide, sir. Sorry, sir.
Okay.
Okay, sir. Okay, sir.
Maybe I can come for a
Quick
quick
review, sir.
thing. Yes, yes.
Sorry, sir.
So as we discussed, the energy efficiency, sustainability, and why it matters. So energy efficiency, as you know, all know that to achieve the same outcome by optimizing by using the less energy. So sustainability meeting present needs with compromising future generations. So why it matters we discussed, right? So the current state of energy use in civil infrastructure, building itself consumes accounts for 40 percentage of global energy consumption, and the construction segment it accounts for 38 percentage of global CO2 emissions. So these numbers highlight the urgent need for change. Civil engineers are in a unique position to address these challenges by incorporating energy efficient designs and renewable energy solutions. So the principles of energy efficient design. So energy efficient design begins with the thoughtful planning. Proper site orientation can maximize natural light and ventilation, reducing reliance on artificial lighting and HVAC systems like heating, ventilation, and air conditioning systems. Choosing low carbon materials like recycled steel or fly ash lowers the embodied energy of construction. And also, additionally, high quality insulation and sealing also matters. So, sustainable building practices. So when you think about the sustainability, we think about renewable energy sources like solar and wind, and they contribute more into the sustainability. And for when it comes to sustainable building, there is water management like rainwater harvesting and grey water recycling, and also green roofs with insulation and high aesthetic and biodiversity. So energy efficiency in civil engineering systems, it's again HVAC optimization because it accounts for more energy consumption, and also lighting efficiency. Nowadays there are LEDs when compared to the olden days incandescent, the CFLs were efficient, and then the LEDs came into the picture, and it offers more lighting. There are variant of color temperatures available as per your requirement for residential or commercial or showrooms. You can go for any color temperature, which means the yellow, warm white, and yellow lights. It depends, and wattage also you can customize. There are variants available to improve the lighting efficiency, and then there are smart technologies like IoT. So the building management systems are available. When it comes to industry, there are energy management EMS systems are available. So it will be incorporated into the remote monitoring systems, so that you can get statistics of the energy consumption, and you can optimize the energy consumption in either residential or any commercial systems. So, role of civil engineers in promoting sustainability. Civil engineers are key to advancing sustainability by advocating for green building codes, educating stakeholders, and adopting innovative technologies. Engineers can design solutions that reduce waste, maximize resources, and align with the principle of a circular economy. So, when it comes to future trends in sustainable construction, uh, we cannot omit net zero buildings, because it's a very good concept. Buildings designed to generate as much energy as they consume, reducing their carbon footprint. A carbon footprint is nothing but I told you already, it's the CO2 emissions. If you are generating 1 unit, how much CO2 emissions you are saving by the production of 1 unit of electricity. So CO2, it matters a lot, because CO2 emission is day by day keep on increasing. The number of vehicles are keep on improving, and there are lot of pollution which causes more CO2 emissions. And then there is advanced materials. The future of construction is shaped by advanced materials like self-healing concrete and some other materials to enhance sustainability. And there is AI and big data, which I told earlier. Based on AI and IoT applications, we can do real-time monitoring of the generation, the proposed capacity required, or the expected data for the next 1 year. All those predictions we can do based on the AI and big data. And then smart cities integrating transportation, utilities, and the buildings efficiently to create sustainable urban environments. So when it comes to sustainability, the renewable energy sources like solar and wind plays a major role in energy efficiency and sustainability. So this presentation gives a little information about the solar power, how it contributes to the energy efficiency and sustainability. So as I told you earlier, it's a clean and green energy. It reduces the dependency on fossil fuels. There is no CO2 emission. It's clean and green. It's a renewable source. It's not a non-renewable source like coal or fossil fuels. And it's very much cost effective, long-term savings. If you install solar, you get return on investment. Return on investment is whatever you invested, you will get returns within 3 to 4 years. So the rest of system life of 25 years, you start generate your own electricity. So there are confusions among the people that solar doesn't work properly, or solar is not beneficial. There are so many speculations about renewable energy sources. The best way is to discuss with the experts and get the proper system designed and installed for your premises, so that you can have a long-term savings on energy bills. It promotes greener and cleaner future, and it's very much a reliable source. So the energy challenge in civil engineering is rising energy demand and dependence on fossil fuels and climate change impact. So when compared to traditional grid, there is no need of any transmission loss, transmission long distance transmission, because in traditional there are transformers and long distance cable losses. Solar power you generate and install at your own site and consume it. Only the excess energy will get exported. So it has so much benefits as we discussed. So when it comes to CO2 carbon emissions, for example, a 10 kilowatt system can save up to 15 tons of CO2 emissions annually. Just think about it. It's a small system. You can install it on your rooftops. If you're consuming if you're paying around 10,000 rupees per month electricity, you can install a 10 kilowatt system, which reduces carbon footprint 15 tons annually. And there are types of solar applications in civil engineering. Rooftop solar, As I told you earlier, there are so many schemes for rooftop, for a residential, for industrial, for commercial, and also there are schemes for agriculture sector also. Because a lot of agri farmers, they don't have access to electricity, or they depend on monsoon rainfall. But when they go for solar, they can even get the returns within 1 year when when compared to residential or commercial. It's around 3 to 4 years. And there are schemes, subsidy schemes available, government benefits are available, and national banks are offering very less interest rate loans. And there are solar street lights which works from dusk to dawn. As I told you, it starts in the evening automatically. When it's sunshine starts in the morning, it goes off. So this is a very good concept of energy efficiency and the sustainability, because lighting itself consumes occupies most of the energy consumption in globally. So in campuses and roads, highways, you can go for street lighting systems, which comes with inbuilt batteries, lithium batteries. Nowadays, there are so many advancements in the technology in street lighting systems. So energy efficiency in solar powered infrastructure. So there is a net zero buildings. Net zero means by using solar power to offset all energy consumption and achieving energy independence. So whatever is required, you generate on your own. That is net zero. It will be called as net zero building. And there are smart grids. So there is a energy storage solution. You generate and then store it. You can use it on peak load. And there are real-time monitoring with IoT. These are some of the recent developments proposed for smart city plans. Street lighting, when compared to conventional street lighting, there are smart street lights nowadays. And there are traffic signals and electric vehicle charging stations. Actually, we are the one installed the first solar charging station in 2016 in Madurai Corporation Office near Koripalayam. And then future trends, there are building integrated PV. Photovoltaic, we call it as the solar panels are called as photovoltaic, from light energy to electricity. So there are BAPV, it's a building integrated PV. So it gives seamless energy generation when compared to rooftop solars. And there are floating solar farms, and there are so many advancements happening in next generation solar panels, where the efficiencies are keep on improving. When the efficiency is more, the space occupancy of solar power gets less. So because in apartments, when you come to consider about apartments and all, the roof area will be the same, but there will be a number of floors and a number of houses. So when each tenant wants to install, each house owner wants to install solar on the roof, the roof space is not sufficient. So there are limitations in going with the solar for apartment owners and all. So the latest, by using latest technologies and high efficient panels, you can opt for solar for many house owners when compared to the earlier products. And then there are solar desalination plants. So that's all. Let's work together to build a more sustainable future, fostering innovation, collaboration, and a shared commitment to environmental responsibility. Thank you all. Thank you for the wonderful opportunity.
Thank you so much, sir. Even the transmission lines have transmission losses, But as a human being, you delivered the session for one more time for us without any losses in your patience. Thank you so much, sir. On behalf of SRIT, I extend my heartfelt thanks to Engineer Panditharai sir for delivering such an insightful and inspiring talk on energy efficiency in civil engineering systems. Your comprehensive presentation has truly broadened our understanding of how innovative approaches in civil engineering can contribute to sustainable development and a greener future. The practical examples and real-world applications you shared were particularly enlightening, reminding us of the significant impact that energy efficient designs can have on our environment and economy. We deeply appreciate the time and effort you put into this session, sharing not only your expertise but your passion for sustainable engineering practices. Your valuable insights have sparked interest and inspired our audience to think critically about incorporating energy efficient methods in their work. Thank you once again for sharing your knowledge and inspiring us all.
Thank you, madam. Thank you so much.
Thank you so much, sir. Participants, if you have any doubts, kindly ask. Shall we wind up, sir?
Yes, madam.
Thank you so much, sir. Participants, thank you so much for your joining and inspiring us.
Hello.
Prabhakaran, sir?
Madam, feedback link, madam.
Yes, sir. Yes, sir. We'll share it now, sir.
Thank you, madam.
Ah. So, thank you so much, sir. Once again, I thank our esteemed speaker, Engineer Panditharai, sir. So, thank you for your words, sir. Thank you so much.
Thank you all.
Thank you all. Dear participants, the feedback link will be shared at the end of the day. Thank you all for joining. And the afternoon session will be started at 2:20 p.m. Thank you all. Participants, please, if you are unable to join in the Google Meet, kindly watch through YouTube link. Thank you. The YouTube link will be shared in the WhatsApp group. Thank you all.